You know, from the car you're driving to the phone in your pocket, have you ever wondered how millions of these incredibly complex products get built with such speed and precision? Well, the secret is in a concept that's over a century old but is always evolving: the assembly line. Today, we're going to dive deep into the art of a line and explore the core ideas behind flow shop production. So let's start with a really big question. Do you think the challenge of making a million identical printers is the same as building a million cars, where pretty much every single one is unique? The answer, as you can probably guess, is a huge no. And that fundamental difference? That's exactly what we're going to unpack right now.
At its heart, flow shop production is actually beautiful in its simplicity. Just picture a river. Everything, every part, every product, it all flows in one direction, from the start to the finish, through a fixed, pre-planned sequence of steps. The goal, the only goal, is to keep that river flowing as smoothly and as fast as possible, getting rid of anything that could slow it down and just getting those products out the door.
Okay, let's begin with the classic, the one everybody thinks of, the pure assembly line. This is the world of Henry Ford, the foundation of all mass production, where every single item that comes off that line is an identical twin to the one that came before it. No options, no changes.
And you see this stuff every single day. Think about your refrigerator, or a printer, or a power drill. You don't get to pick a custom color or a special engine, right? You get a standardized product. It's that absolute total uniformity that gives this production method its incredible power and its mind-boggling efficiency.
But listen, simple does not mean easy, not at all. There are three huge scheduling puzzles to solve here. First up is line balancing. You have to make sure each person's job takes roughly the same amount of time. If one station takes 60 seconds and the next takes only 30, you've just created a massive traffic jam. Second is lot size. How many washing machines do you make before you switch over to making refrigerators? Getting that number right minimizes expensive downtime. And finally, parts supply. If you run out of a single tiny screw, guess what? The entire river just stops flowing. It is a constant, high-stakes, logistical dance.
All right, let's evolve the concept a bit. What if you're not just snapping together pre-made parts? What if you're starting with a raw, solid block of material and you have to shape it into something complex? Well, welcome to line processing.
We're talking about the heavy-duty heart of a machine here. Think about an engine block, or those super intricate gears inside a transmission. They start out as just a hunk of metal, and then they're automatically passed from one massive machine to the next, getting drilled and milled and shaped with unbelievable precision.
Now, the challenges here might look similar, but there's a huge twist. Line balancing is still absolutely key, but now it's about machine time, not human labor. The real efficiency killer, though, the thing that keeps managers up at night, is changeover time. See, every single second a machine is being switched from making one part to another is a second the entire line is stopped, making nothing. So the master puzzle becomes figuring out the perfect sequence and quantity of parts to make that costly downtime as short as humanly possible.
And now, for the final boss of flow shop production. This is where we assemble products that are just loaded with customer-chosen options. This is where mass production smashes into mass customization, and the complexity just goes through the absolute roof.
The perfect example, of course, is the modern car. But it's also true for trucks, tractors, and all that heavy construction equipment. Unlike that standardized washing machine we talked about earlier, here, almost every single unit coming down the line is one of a kind. It's got a different color, a different engine, a different interior, you name it.
And this just brilliantly illustrates the scale of the problem. A single car model can have over 1 million possible combinations. So how on earth do you manage that on one single assembly line without it just falling into total utter chaos?
This brings us to the absolute core principle of this whole thing. With this much variation, the master puzzle isn't deciding what to build. I mean, the customers have already decided that with their orders. The multi-million-dollar question is deciding the exact sequence, the order in which those unique products enter the assembly line. That one decision impacts literally everything else down the line.
And the solution has a name. It's a concept called leveling, or heijunka. Schedulers, often with the help of some seriously powerful AI, have to balance 4 things all at once. First, you can't put 3 cars that all need a sunroof, a job that takes a long time, right in a row, or you'll create a bottleneck and stop the line. Second, you can't give one worker all the physically tough jobs back to back and burn them out. Third, you have to smooth out the use of parts so your suppliers don't suddenly get an order for 50 red doors in 10 minutes. And fourth, you have to mix up the finished products so you don't overwhelm the shipping yard with only huge trucks. It is an incredibly complex, 4-dimensional balancing act.
So let's bring it all back together. We've looked at three really distinct flows, right? From the super simple to the incredibly complex. But the thing is, they are all chasing the exact same goal: creating that perfect, smooth, uninterrupted flow to deliver products as efficiently as possible.
And this final comparison really makes it crystal clear. We go from standardized products where balancing the line and supply is the name of the game, to processed parts where the biggest win is slashing that changeover time, all the way to customized products where the entire game is won or lost based on one thing: optimizing that input sequence.
And that, of course, brings us to the future. As AI gets smarter and our data gets more powerful, our ability to optimize this flow is just going to explode. And that means more customization, more efficiency, and probably products that we can't even imagine today. So the next time you configure a car online or you see a new gadget, just think about the incredible, complex dance that's happening behind the scenes to make that thing a reality. Thanks for joining me.